Okay, now we'll discuss how to find coefficients for the closed form of generating functions. So our starting point will be the binomial theorem. So we know generating functions are used to formulate counting problems in a different format, which we had already discussed in the first session. Okay, and we have also discussed how to write the closed form of generating functions. Now we come to the utility of generating function, how to write the coefficients from the generating functions. So for that you should always remember the binomial theorem, which we have discussed in the last session. We have extended the binomial theorem to any real number. Okay, so the formula for 1 plus x raised to n is 1 plus nx plus n into n minus 1 into x square by 2 factorial plus x, etc. We have discussed what is NCR in the context of n being any real number. Okay, so using that, and also for the negative integers also we have discussed. So in that case the binomial theorem will reduce to 1 by 1 plus x raised to minus n is equal to minus nc0 minus n1 nc1 raised to x, etc. So this will be a infinite series. So this will be our key point in discussing how to obtain the coefficients from generating functions. So with all these ideas in our mind, let us now do some problems now. So first let us discuss how to find the coefficient of x raised to 5 in 1 minus 2x the whole raised to minus 7. Okay, so just remember the binomial theorem. It is in the case of negative integers is this. You should remember this result. So we will use that result here. So what will be the expansion of this be? It will be nothing but, so it will start with minus 7 c0. Okay, then it will be minus, please write it with me only, then you will understand. Minus 7 1 into minus 2x plus, again it will be minus 7c2 into minus 2x the whole square, right, plus etc. So when you have to write the x raised to 5 will come in the term with 2x raised to 5, so it will be plus minus 7c5, okay, into minus 2x the whole raised to 5. So it will go on like this. So we only require this coefficient where the power x raised to 5 comes. So this is the term which we are looking at. Okay, now this term, the coefficient of this x raised to 5 in that term is nothing but minus 7c5. Okay, then minus 2 raised to 5. So what is the meaning of this? We have discussed this yesterday. It was minus NCR is nothing but minus 1 raised to r n plus r minus 1 cr. We have discussed this result yesterday. So using that result, this will be minus 1 raised to 5, okay, into minus 2 raised to 5. It is already there. Then 7 plus 5 minus 1 c5. Okay, so that is you will get this as 32. Then 7 plus 5 is 12 minus 11 is 11 c5. So this is the coefficient of x raised to 5 in minus 2x raised to minus 7. Now if you have scientific calculator, you can obtain the value of this. Now I hope you understand how to find the coefficient from a power like this. Okay, so we will do more problems and you will understand. So your starting point should be the binomial theorem. You should understand how to write the expansion of binomial theorem. Only then you will understand how to write these problems. Okay, again let us look at this problem. X raised to 5, you have to find the coefficient of x raised to 15 from this product. Okay, now we'll discuss how to find the coefficient of x raised to 15 in x square plus x cube plus x raised to 4 the whole raised to 4. Okay, so let us write down it once again. So we have x square plus x cube plus x raised to 4 plus etc. the whole raised to 4. You can see that x square is a common factor here. So if I take x square outside, it will be x square raised to 4 into 1 plus x square plus etc. the whole raised to 4. That is actually x raised to 8 into 1 plus x square plus etc. the whole raised to 4. So we need the coefficient of x raised to 15. Now this consists of x raised to 8 into something. So in effect we need the coefficient of x raised to 7 in the expansion of 1 plus x square plus etc. the whole raised to 4, right? So how will you expand this? So we know that what is the value of 1 plus x square? We know from familiar infinite series that the value of this quantity is nothing but 1 by 1 minus x the whole raised to 4. This is actually 1 minus x the whole raised to minus 4. Now we will apply the binomial theorem. So when you apply the binomial theorem, this will be actually 4c0 plus minus 4c1 into minus x plus minus 4c2 into minus x whole square plus etc. When it is x raised to 4, it will have minus 4c4 into minus x raised to 4 plus etc. So this is the coefficient which is associated with x raised to 4. So that is actually minus 4c4 into minus 1 raised to 4. This is nothing but minus 1 raised to 4 into 4 plus 4 minus 1 c4. Okay, this is the value of minus 4c4 into, already we have one more minus 1 c4 here, so we are getting the value as 8 minus 1, that is 7c4, which is the coefficient of x raised to 7 in 1 minus x raised to minus 4, which is in fact the coefficient of x raised to 15 in the given function. Okay, so we have liberally used the ideas from binomial theorem and also simplification in computing the value of x raised to 15 here. Okay, similarly we will see other problems also. Suppose you are looking at this problem, so just read this question. So in how many ways can how many ways a police captain distribute 24 rifle shells to 4 police officers so that each police officer gets at least 3 shells but no more than each. So there are actually 24 in all. This is just like a selection problem. We have 24. We have to distribute 24 rifle shells, and there are 4 police officers. It's similar to our problem which we are discussing in earlier classes. X1 plus x2 3 plus x4 is equal to 24, and the value should, the restriction is that each officer should get at least 3 shells but no more than 8. So it is 3 less than or equal to xi should be less than or equal to 8. So when you approach the problem using our generating function, so the selection will be like this. So at least 3 should be there. So one police officer should have x cube plus x raised to 4 plus etc. plus he can get up to 8. Okay, the second police officer also can have the same generating function. So in effect, when you take account all the police officers, this is the generating function of the sequence. Okay, now in order to solve this problem, we are asking you to find how many 24 rifle shells have to be distributed. So you have to look at the coefficient of x raised to 24 from this product. So this formulation we have already talked in our first session, so I hope you understand the formulation, and the only thing we need now require is just the coefficient of x raised to 24 from this problem. Okay, so how will you find it? Similar to the earlier problem, we take x cube, we can take it outside, so it is x raised to 12 will come outside, so remaining is 1 plus x plus etc plus x raised to 5 would be there because x raised to 12 is already out, the whole raised to 4. Okay, now how will you do it? So you can, using the familiar calculus result which we discussed earlier, this can be written as x raised to 12 into 1 minus x raised to 6 divided by 1 minus x, right? So the whole raised to 4. Okay, so you need the coefficient of x raised to 24, or you just need the coefficient of x raised to 12 from this product. Okay, so what is it? So we have two things here, that is 1 minus x raised to 6 the whole raised to 4 into 1 minus x raised to minus 4. So we will just take the product, and from that we will find the coefficient of x raised to 12 from that product. Okay, so how will you do it? We will apply the binomial theorem there itself. So it is actually 4c0 plus again 4c1 into minus x raised to 6 plus again 4c2 into minus x raised to 6 the whole square, that is minus x raised to 6 the whole square, that is again minus x raised to 12. Again you have 4c3. I am just applying the binomial theorem here. 4c3 minus x raised to 6 the whole cube there, but there is not required because these terms are not required. So maximum you need is actually up to x raised to 12. So I will just stop it there into what you are writing, 1 minus x raised to minus 4, that is actually minus 4c0. Okay, minus 4c0, then plus minus 4c1 into minus x, again plus minus 4c2 into minus x square, so minus x the whole square. Okay, then it will go on like that, minus 4c3, so it will go on like that, plus minus 4c3 into minus x the whole cube plus etc. Okay, now we will discuss when is the power x raised to 12 coming in this product. Okay, so when is the power x raised to 12 coming in this product? Okay, so when you multiply the constant term with the power of x raised to 12 here, you will get a term of x raised to 12 here. So the constant term is actually 4c0 when it is multiplied by the term containing x raised to 12 there. So what's the term containing x raised to 12 in this expansion? So it is nothing but minus 4c12, okay, into, I am just writing the term itself, so it is basically minus x raised to 12 will be coming from that, plus again when will again x raised to 12 come? So when I multiply this x raised to 6 with a term containing x raised to 6 here itself. So what is it? So when you multiply that, what will you get? So you'll have again 4c1 into minus x raised to 6 from the first term is being multiplied by the term containing 4 x raised to 6 in the second term, that is nothing but minus 4c6 into minus x minus 4c6 into minus x raised to 6 there. Okay, then finally, and what's the next term involved? Okay, so here also you have 4c2 minus x raised to 6. So actually you have already got here minus x raised to 12. So when this is multiplied the constant term here, so we'll be getting 4c2 into minus x raised to 6 the whole square into minus 4c0. Okay, so only if you write with me you will understand how these terms are obtained. So only these three terms will be containing x raised to 12. Rest everything it is powers of higher greater than x raised to 12. Now let us try to simplify it a bit. So what is this? This is actually 4c0, that is actually 1. And what is minus 4 12? That is nothing but minus 1 raised to 12 into 4 plus 12 minus 1. So it is 4 plus 12 minus 1 c12. Again I am omitting the x factor here, so it is nothing but minus 1 raised to 12. We're taking that, so it is x raised to 12 there. So next coefficient would be again 4c1, which is again 4. I am omitting that x factor here, so it is simply minus 1 raised to 6. Then again it would be 4 plus 6 minus 1 c6 into minus 1 raised to 6 from there, and also for the second term itself we have minus 1 raised to 6 there also. And finally we have this last one, it is 4c2, so it is actually 4c2, so just compute that 4 into, so it is 4 into 3 by 1 into 2 there, and minus 1 square will be there. Okay, then you have minus 4c0, that is again 1. So when you simplify this, this would be your coefficient of x raised to 12 from that product. So just simplify this, so you will get this as 4 plus 12 minus 1, that is 16, that is 15c12 will be there. Okay, then plus 4, again that is 10, 9c6 would be there. Okay, again you have 4 into 3 by 2, that is again 6 will be there. So when you simplify you will get the answer. So this is the coefficient of x raised to 12 from the second product here. So this is the coefficient of x. So you require the coefficient of x raised to 24. Okay, so when you took x cube outside, you had x raised to 12 outside. So this is the form term which we found was the coefficient of x raised to 12 in this term. So in total it will be the coefficient of x raised to 24. So the answer is, once again let us look it. You just took it outside, you applied binomial theorem, you have to write it on this, you want to understand, and this is the term involving that. Simplify it, you will get the answer. Okay, so that is another way of computing the coefficient of x raised to 8. So next we will try to another problem, which is again compute the coefficient of x raised to 8. So this also you can do the same approach here also. Okay, you can take the expansion of x minus 3, then you can take the expansion of x minus 2 the whole square, and you can multiply, and you just pick out the term so that you get the product as the power as x raised to 8. So you can pick it out like that. Now I'll teach you another approach also in using another method also. So I'll just teach you another approach using partial fraction. So you can use many methods. So I am going to teach you partial fraction approach also to solve this problem. For that I'll write this term in terms of partial fractions. So I'll write this as a by x minus 3 plus b by x minus 2 plus c by x minus 2 the whole square. We have studied this partial fractions approach in your calculus classes in your lower semesters. Okay, so you will find the value of ABC. So I'll write this term is equal to 1 by x minus 3 into x minus 2 the whole square. We will find the value of a comma b comma c. So how will you find it? So a into x minus 2 the whole square plus b into x minus 3 into x minus 2 plus c into x minus 3 would be 1. So when x is equal to 3, what will you get? This will become 0, this will become 0. You get the value of a as simply 1. Okay, so similarly when x is equal to 2, this will become 0, this will become 0. You will get the value of c as simply minus 1. Okay, so you put x is equal to 0 to find the value of b. Okay, so this will be 4a would be there. When x is 0 here, you will have plus 6b would be there. So minus 3 minus 2, so 6b would be there. So x is 0 here also. So here this 4a is there. So a value of a is 1. So I'll just write that 4 there. Okay. So when the value of c is x minus 3, when x is 0, this is minus 3, but the value of c is minus 1, so we'll get this as again plus 3 is equal to 1. From this, when you simplify, you will get 6b is equal to 6b is equal to minus 6 over the value of b is minus 1. Okay, so this can be written, this term now can be written as, okay, so the value of a, so this term can now be written as, I will write this, I will write it down somewhere here. Okay, so just a second. Okay, so I can write this as 1 by x minus 3 minus 1 by x minus 2 minus 1 by x minus 2 whole square. Now we'll expand it using binomial theorem. So I'll write this of the form 1 by 1 minus x. I'll rewrite this. So for that I'll take minus, I'll take 1 here. I'll take minus 3 from the denominator. So it is 1 minus x by 3. So if I write it like this, I can give the expansion of 1 by 1 minus x there. Okay, minus 1 divided by, again I will take minus 2 outside. So it is 1 minus x by 2 there. Okay, so similarly the last one also, if I take minus 2 outside, it will be simply minus plus, okay, plus, so it's minus of, okay, minus of 1 by, if I take minus 2 outside, it will become plus 4. Okay, so it is 1 minus x by 2 the whole square. Okay, so I took minus 2 outside, so it became minus 2 square, so it became plus 4 there, so minus 1 by 4. So these are the terms. Now we'll expand it. So the first expansion would be minus 1 by 3 is there, then the rest would be 1 plus x by 3 plus x by 3 the whole square plus etc. This is from binomial theorem. Okay, the second expansion would be minus, it will become plus, so it will be plus 1 by 2 into 1 plus x by 2 plus x by 2 the whole square plus etc. And the third term, it is a bit difficult, so first I'll write this as minus 1 by 4 into 1 minus x by 2 the whole raised to minus 2, and we'll now apply the binomial theorem for that also. So the last term, if I rewrite it, it is nothing but minus 1 by 4 into minus 2 c0 plus then minus 2 c1 into minus x by 2. The second term, please write it down. What is it? Minus 2 c2 minus x by 2 the whole square plus etc. Now we'll pick out the terms involving x raised to 8 from everything. So from the first term, so the first polynomial term involving x raised to 8 is minus 1 by 3 into, I'll just write the full term for your reference, x by 3 raised to 8. I'll include x raised to 8 there also, plus in the second product, the term involving x raised to 8 is nothing but x by 2 the whole raised to 8. Okay, and from the last term, the term involving x raised to 8 is minus 1 by 4 is lying there. So just observe here what would be my x raised to 8. So it will be actually minus 2c8. For that you will have minus x by 2 the whole raised to 8. Okay, so these are the terms involving x raised to 8 here. Now we simplify this, we will get the answer. So this is nothing but minus 1 by 3 into 1 by 3. So the coefficient is, it is into 1 by 3 raised to 8, then plus 1 by 2 half and 1 by 2 raised to 8, and the last one, it is minus 1 by 4 into, now minus 2c8 is minus 1 raised to 8, then 2 plus 8 minus 1 c8 by definition, and it is minus 1 by 2 raised to 8. Okay, now we can find, I hope you understand these values. Just substitute the values, simplify it, that will be a coefficient of x raised to 8. So you can find the answer using the calculator. Okay, so this is how you find the coefficients in each and every problem, and we will do one more problem so that we can close the section. Okay, one more problem is there. Okay, so just read the question at once. This is very important. This can come for your examination also. So it's from your exercise problem. Or we can try to first formulate the problems. So in how many ways can 2 dozen identical robots? So basically we have 2 dozen. So 24 robots have to be distributed. So remember, you need the coefficient of x raised to 24 here. Okay, so 2 dozen. So they are being distributed in 4 assembly lines. So basically they are being distributed in 4 sets. So we need to give, maybe we'll be supplying some 4 robots here. We'll be supplying 10 robots here. We'll be supplying 3 robots here. Maybe we'll be supplying, so now we have 8, so 7 robots here. Okay, so we'll be supplying robots into these 24 robots into these 4 assembly lines, and 2 questions are being asked. At least 3 robots should be assigned to each line. So the case would be, you can take, so the first assembly line, x can be x cube plus x raised to 4 plus etc. plus up to how much will it go? So each of them should have at least 3. So the maximum that can go for one assembly line is, total there are 24. So these 9 should be given to others also, so the maximum they can go is up to 6 raised to 15. So this can happen for each of the assembly lines. So you will find the coefficient of x raised to 24 from this product. Okay, so that is how you deal with the first problem. Please try it yourself. You can take x cube outside, you just try to take it outside and you supply it and you can find the answer also. So one more thing I would like to stress is that even if you write this as an infinite series, it will be much more easier to do it here. So if I do it like this, that means here also the factors of x raised to 15 are there, x raised to 16 are there. Okay, so if you write it as an infinite series also, you can find the answer. The answer will be correct only, because the factors involving x raised to 16, x raised to 7, etc. will never be used for the computation of x raised to 24. Why? Because once you take x raised to 16, the next product automatically starts from x cube. Okay, so when you multiply it, you will obviously, when you take the product of all the 4 factors, it will go beyond 24. So we won't be using the factors involving x raised to 16, x raised to 17 also in the computation. So you can just take this as an infinite series. So the use when it is an infinite series set is that it is easier to compute, because if you once you take x cube outside, it will become x raised to 12. The rest of the things is, but it is simply 1 plus x square plus something, etc. So that is very easy to write it, because it is actually x raised to 12 into 1 by 1 minus x raised to 1 by minus x raised to 4. So this is easier to compute using the binomial theorem. Okay, so if you take it as an infinite series also, there is no issue, because we are not using the products involving or the powers involving greater than 15, that is 16, 17, etc. for the computation of x raised to 12 here. So that also you can for the computation of x raised to 24 here. Okay, so you can also take it as an infinite series. Now see the second question. In this formulation you should be very careful, because they have already told that it cannot be more than 9. So in the formulation of that problem, how will you write? They have told you that you have to arrange in such a way that one line should have at least 3 but no more than 9. So in that case you cannot apply infinite series, because if you take 10 also, those possibilities can add up to 24. So you have to be very careful. So when you formulate the second problem, it will be like x cube plus x raised to 4 plus etc. plus x raised to 9 for each line, the whole raised to 4. Okay, now in this one you have to find the coefficient of x raised to 24. So you have to formulate it like this only. You cannot take x raised to 10 or 11 there, because when you take x raised to 7, there is a possibility of them being used for the computation of the factors of x raised to 24, but that is not possible, because the maximum power that can come here is just x raised to 9. Okay, so we cannot simplify it there. So you have to use the familiar method, that is, you will take x cube outside, rest you will be 1 plus x etc. x raised to 6 would be there. Then you will write this as 1 minus x raised to 7 by 1 minus x in the previous problem, and then we will compute the value of x raised to 8. Okay, so this is how you will compute the coefficients of generating functions. I hope you understand this. Please try to do some problems in the exercise section also. Thank you. Stay safe.